Understanding Network Topologies in Wireless Communication. Understanding Network Topologies in Wireless Communication. Wireless communication is an indispensable technology, powering mobile devices, remote sensors, and IoT devices. Wireless networks can be classified according to their topology, which refers to the arrangement of their components. Understanding the different network topologies is essential for designing, implementing, and troubleshooting wireless networks. In this article, we will explore the common network topologies in wireless communication, their advantages and disadvantages, and some practical examples. Mesh topology. The mesh topology is a highly resilient and scalable network arrangement used in many wireless applications. In a mesh network, every node or device is interconnected with every other node via multiple short-range connections. Mesh networks can be self-forming, meaning that nodes can join or leave the network without requiring manual configuration. Mesh networks are also highly redundant, with multiple paths between nodes ensuring that communication is not interrupted if one connection fails. Mesh networks can be used in many applications, including smart grids, wireless sensor networks, and home automation systems. One example of a mesh network is the Zigbee protocol, which is heavily used for smart home automation. Zigbee allows for scalability, meaning that new devices can be added to the network without chaos. In conflicts or degradation of performance. In a Zigbee mesh network, a device could serve as both a router and an endpoint, allowing messages to be forwarded through the network. Star topology. In a star topology, a single central point, such as a hub or a switch, connects all the nodes in a wireless network. The central point acts as a relay, forwarding messages from one node to the other. Star networks are easy to set up and manage, with the central point acting as a bottleneck to communication traffic. Star topologies are commonly used in Wi-Fi networks, where a router acts as the central point, and wireless clients connect to it. One advantage of a star topology is that it isolates problems. If one node fails, it does not affect the other nodes and does not bring down the entire network. At the same time, the central point is a weak link, and if it fails, the entire network goes down. The star topology is also not as scalable as other topologies since the capacity of the network depends on the capacity of the central point. NT. Ring topology. In a ring topology, the nodes are connected in a circular arrangement, with each node communicating with its neighbors in a unidirectional manner. In other words, data travels around the ring until IT reaches its destination. Ring networks are not widely used in wireless communication, but they can be found in some industrial control applications. One advantage of a ring topology is that it guarantees fairness since each node gets an equal chance to transmit data. However, the reliability of the network is limited since failure of a single node can bring down the entire network. Moreover, the bandwidth of the network decreases as the number of nodes increases. Tree topology. A tree topology consists of nodes arranged in a hierarchical structure, similar to a tree. The root node is the top-level node, and each node can have multiple child nodes, forming branches and leaves. Tree networks are commonly used in hierarchical control systems, where a central controller communicates with multiple end devices. One advantage of a tree network is that it is scalable, and new nodes can be added while maintaining the hierarchical structure. Tree networks also provide isolation between branches, allowing common ication between nodes without interfering with other nodes. However, tree networks are not as resilient as mesh networks, and a single point of failure in the hierarchy can affect multiple nodes. Hybrid topology. In a hybrid topology, two or more network topologies are combined to form a more complex network arrangement. Hybrid topologies are common in larger wireless networks,